Hello, dear students. Welcome to the Quantum Grow. Let's see this question number 3.22 of Irodov. The question states, each of the two long parallel threads carries a uniform charge lambda per unit length. The threads are separated by a distance L. Find the maximum magnitude of the electric field strength in the symmetry plane of the system located between the threads. So suppose this is my infinite wire, long wire carrying a uniform charge density lambda at a distance r from here. Electric field will be radially away, like 2k lambda by r at this point, 2k lambda by r at all such points. Electric field will be radially away. Radially away mean perpendicular to the wire and away if the charge density is a positive. So I have a combination of two such wires like this, and identical charges, and they are separated by some distance. Say the distance is L, and let me hold it like that. So exactly in between them the electric field would be zero. And if I, this is a line joining them, and the perpendicular along the perpendicular to the line joining them, if I go like that, here electric field is zero. So at a very large distance, again electric field will be zero. So here 0 and at infinite separation 0. So somewhere between them, the electric field would first increase and decrease. So somewhere between them, electric field would be maximum. And first of all, we'll have to find where the electric field will be maximum, and then the maximum magnitude of the electric field. So it would be better that if in place of this orientation, if I keep the wires in this orientation. So I will keep the wires in this orientation, and if these are the two orientation like this, or you can see along my two fingers, and then electric field I'll calculate along the line joining them and perpendicular to that, something like this. So these are my two infinite wires, and they have the same charge density, plus lambda and plus lambda. This is plus lambda, and this is also carrying charge density plus lambda. This is the line. Obviously, exactly in between them, the electric field will be zero, and I'll go along this line, and at infinite separation, electric field will be zero. So we'll find at which point electric field is maximum. So first of all, let me take a general position. Say here, somewhere here. That is from here, suppose this distance is L by 2, and this distance is L by 2, and suppose this is Y. Once again, let me reorient. My wire is along this direction, and this point is like this. So at this point, if this is the wire, electric field will be along this direction. And with respect to this wire, if the point is along this direction, electric field will be along this direction. So suppose, as symmetry says, suppose this distance is R, this is R. So because of this wire, the magnitude of electric field is E along this direction away. And because of this wire, magnitude of electric field is also E along this direction. And if this angle is theta, so will be this angle, and their vector sum will be along this direction, and this is theta, this is theta. Their cos theta component will add up, and sine theta component will cancel. So the net electric field is going to be 2e cos theta. So I have E net is equal to 2e cos theta. And what is E because of the one wire? Obviously, because of one wire, E is a 2k lambda divided by small r. Small r is the distance from this wire to that point on this line. And what is cos theta? You can see from this diagram, cos theta you can see clearly is y by r. So y by r, so I have now 4k lambda y by r square. And let me put the value of r. You can see from the diagram, so this is a 4k lambda y divided by r is a y square plus L by 2 whole square root, and if I put the square, so that will be simply y square plus L square by 4. So E net is maximum where when dE net by dy is 0. So let's differentiate with respect to y. So what I'm going to get, 4k lambda will come out, and in the denominator that will become y square plus l square by 4 whole square. Apply quotient rule. Differentiation of y is 1 and the other term is y square plus l square by 4. Role reverse, put y as it is, and the derivative of the denominator is simply 2y, and this all things should be 0. So the whatever is inside the bracket should be 0. So this is y square, this is minus 2y square, mean y square should be l square by 4. So it means E net is maximum where at y is equal to L by 2. And on this direction also. So it will give answer also y is equal to plus minus L by 2. So either way you can put. So now put y is equal to L by 2 on this equation here. So maximum value of electric field, we are going to get E net max. E net max will be 4k lambda. Y is L by 2 and y square is L square by 4. So L square by 4 plus L square by 4. So that would be how much? 4k lambda L by 2 and divide by L square by 2. So that will be 4k lambda by L. And put the value of k, which is a 1 upon 4 pi epsilon naught. So we will have lambda by pi epsilon naught L. That is my E net max. And this is our answer. Thank you.